Welcome back, everybody. This is episode 16 of the Multi-Cloud Network Architecture series. And today we're going to be talking about replacing your MPLS with a global cloud backbone. Yes, it's possible. Yes, people are doing it. And yes, it works. I'm really excited for this episode because I've been wanting to do this for a customer for so long. It just makes so much sense. Today, I've invited special guest Frey Khademi, who is a Senior Systems Engineer with me at Aviatrix, and Tomasz Klimczyk, who's a Senior Solutions Architect with me at Aviatrix, to talk to us all about what they're seeing with their customers in the field. Thank you so much for being here, guys.
Hey everyone, this is Tomasz. Thank you, Dana, for having me here again.
Thanks a lot for having me, Dana. So my name is Frey, and I'd like to talk today about a design that we're working on with a customer. So we were approached by a large global organization. So they have a large global network, everything interconnected with an MPLS backbone, and it's working fine. It's very reliable, but they've had a couple of challenges over the past little while. It started when they started to adopt more and more cloud. So they started going into not just one cloud, but into multiple clouds, multiple regions, and they have cloud first strategy. So everything needs to go into the cloud, and just connecting and making sure everything is interconnected with each other and has connectivity is a challenge. The other challenge that they have is just with MPLS in general. So for sure, it's very reliable, but the amount of data and stuff like that they transfer over their MPLS costs a lot. So very high costs, and then onboarding new sites or after an acquisition, onboarding a new company onto their MPLS takes a very long time, and so now they have a kind of cloud first strategy, and actually one of the things that we're helping them with, which is super interesting. So we're building a global network, a global transit network, using Aviatrix Transit across various regions around the world, and we're using the cloud providers' backbones to get high performance connectivity between. So globally, and we're connecting so rather than the sites and everything connecting into their MPLS, so we'll connect them directly into the transit. And so from the Aviatrix platform, using our controller, and so you've shown that in a lot of the other videos you've done, so we can very easily create site to cloud links and automate that through one central place. With all so BGP route propagation, with the route summarization that the customers need and stuff like that, and route approvals and all that kind of stuff.
Yeah, Frey, this is really interesting, and it seems to resonate well with majority of my customers as well. And I think it's because customers are starting to see more value in their connectivity from branch to cloud than they are from branch to branch or branch to data center. As the center of gravity changes in the network to the cloud, it makes more sense to put more value in their connectivity to the cloud, in their efficient connectivity into the cloud. And if you think about it, MPLS architectures are very legacy, right? They were designed to connect sites to each other and sites to data centers. And if that's no longer the priority, the relevancy of MPLS is becoming less and less. And essentially, you can build your own MPLS-like backbone using these high performance and highly reliable cloud backbones, right? And that's what your customer's looking to do.
Exactly. And so it was it's great to see that customers also realize that, and using the Aviatrix platform. So it's amazing how fast they can actually deploy this type of environment.
Right.
So just within a couple of days, you can build this entire infrastructure as code, which means you're super flexible. You need to redo something. Everything is repeatable. So they go from, if they do another acquisition and they need to onboard maybe some sites in Africa or something like that, rather than waiting for their MPLS provider to onboard those sites, they just, they have it connected to the Aviatrix Transit.
Yeah.
And the entire infrastructure, therefore, in no time.
Yeah, so and the transit architecture will handle the connectivity between clouds, within cloud, between remote sites and data center. That transit will pick the optimal path depending on the region to get there. And so I think a lot of the pushback that I would get from a traditional network architect or a traditional networking person because, putting myself in those shoes, I spent the last 10 plus years in those shoes. The pushback would be like, well, I'm moving from an any-to-any MPLS to a hub and spoke cloud-based model. But you know what? Really, under the covers, it's just a bunch of regional hub and spokes. It's not an any-to-any like you think it is. Logically it is, but really what's happening is that these sites are hitting POPs, points of presence, in their regional locale, and then those POPs are getting them to where they need to get to. And you can build the same thing out in an efficient manner using these highly available cloud regions and put your own POPs in there. And I pretty much will guarantee you that your performance is not going to suffer. If you do some analysis, I bet you'd have lower latency and better performance between certain regions, between certain countries, by leveraging these amazing cloud backbones.
That's a really, really good point. And so actually this customer did the analysis, and they actually do have much better, so more than twice as better performance using the cloud provider's backbone, as well as huge cost reductions. So
I believe
which is also an amazing thing to see. And let's say today I want to deploy this transit on the AWS backbone as an example. Mm-hmm. It's just as easy to repeat that and deploy the exact same thing, or maybe to move your transit to Azure, or to another cloud provider, mm-hmm. because maybe the data transfer rates are cheaper or whatever, or maybe you get better performance, better security, that kind of stuff.
Right. And I think that's a really good point. I think the next pushback was a couple pushbacks that I want to address here, just thinking through, with MPLS, you have some pretty nice traffic engineering control sets. You have the tools to engineer traffic to go left or right, to take a certain path, to have deterministic failover, right? You can play with BGP attributes to get things to go the way you want them to go. But if you terminate a site directly into the cloud, you lose all that intelligence. Right? If you took a remote site and just put an IPsec connection to a TGW or VGW or whatever construct in the cloud, you lose all that BGP path attributes. You lose the visibility into that. You can't control it, which is not a good idea, right? But if you leverage Aviatrix in the cloud, you get all that back. You have all that intelligence back because Aviatrix runs the BGP stack. We support all that traffic engineering, summarization, the filtering, the route control, the best path algorithm, right? We handle all the route propagation for you end to end. So you actually are not losing that. And the next pushback I think you might hear is customers are going to say, well, you know what? I had an SLA with MPLS. I don't have an SLA with cloud backbone or internet connectivity into the cloud. And while that's true, what they don't realize a lot of times that the internet is insanely reliable now. It's so incredibly reliable. And that's why people have been moving from MPLS to SD-WAN, because they trust the internet. And in our solution, you can spin up multiple tunnels to a remote site, multiple high availability, equal cost multipath tunnels to remote sites in minutes, so you get that HA there. And if you really, really wanted some measure of resiliency from a packet level perspective and some SLA-like behavior, then you can throw SD-WAN on top. And we have SD-WAN architecture integration architectures that I've shown in previous videos. With SD-WAN, you could do things like forward error correction and packet duplication if you really wanted to. I don't think it's necessary in my opinion, but I just think it's mind-blowing that with the center of gravity changing to the cloud, we no longer really have this need for an expensive MPLS that you have no control over. Frey, this is fantastic. What other benefits does the customer get to realize by leveraging Aviatrix as their network cloud platform to build this next generation cloud network?
Yeah, so there's a couple of additional things. So we've got the transit down. We're connecting all the VPCs and sites, and now the next thing that we're going to add in is next generation firewalling in the cloud. So in a scale out kind of architecture, we're going to be implementing secure egress, controlling where all of the resources can go out on the internet. And then obviously there's the segmentation part, which is a huge gap in the cloud. So being able to create segmentation domains and stuff like that. And then lastly, on the security side, everything in this architecture is end-to-end encrypted, which was a huge plus over MPLS and over what they had before. And Tomasz, we're working on this one together. So maybe there's a couple of other things you want to mention.
Sure. So now looking at the big picture over here, now this customer has a very repeatable architecture. As you can see today, we're looking into AWS and Azure for this particular customer. But any minute, any day, they may decide that they need to onboard GCP or Oracle. In that case, they can actually leverage all of the Terraform scripts that they have written so far and move them over and deploy all of those resources, all the same architecture in a very similar fashion in any other cloud. So for me, this is probably the biggest advantage that the customer is getting from leveraging Aviatrix. The architecture that they can repeat in every single cloud, every region that they will eventually go into.
Yeah, Tomasz, that makes a lot of sense to be able to have this repeatable across multiple clouds in a really easy way using Terraform. I can see that being leveraged by all of my customers. Now, I want to mention a couple other things that I saw about this architecture that I really love. Number one, I love that you have this cloud access layer where it doesn't matter where you're coming from, if you're at a data center, at a remote site, or you're just a remote user anywhere in the world, you're all ingressing and egressing the cloud via this optimal global transit layer. Everybody's coming in through these regional points of presence where you can gracefully insert services like next generation firewalls and get additional visibility with our platform called Copilot. So you have a really unified way to enter the cloud and have the most optimal connectivity into the cloud. So Tomasz, I know that you've also been working on a similar design for another customer. You mind sharing that with us?
Sure thing. So this is the customer that I also have here in Europe. The scenario is kind of similar. This is a big worldwide known brand that has their offices all across the world. They have a single big data center here in Europe. They are leveraging at least 4 different regions in Azure. And as you can see, there's a mix of MPLS backbone and express route circuits to provide the connectivity between the data center and the branches, and also between the data center and all of the cloud resources. As you notice over here, branches actually talk to the cloud resources currently using egress security solution. I don't want to name drop, but you can probably figure out at least a few options for them to leverage. The challenges are exactly as you've been discussing before with Frey. The cost of the MPLS backbone is tremendous, and the customer is just not seeing any longer the benefit of leveraging MPLS backbone, when instead they could be using cloud providers backbone. And if you think about it, these days, the cloud providers are the biggest telcos in the world. They actually have the backbone which tops any other telco provider out there in the world. So why not leverage those backbones, those fibers that they have laid all across the oceans, and leverage them for your business? Doesn't it make sense?
Yeah, it makes a lot of sense.
Totally. So as you can see, we have lots of branches here, data center, some regions in Azure. This is their current design. And now I will show you the design that we have proposed. Instead of leveraging the MPLS backbone, we're leveraging the best in class cloud providers backbone. Seriously, nothing tops that today. So instead of leveraging Azure Express Route to connect to the old school legacy MPLS backbone, we're using the cloud provider's backbone. We're building Aviatrix high-speed encrypted transit backbone on top of the cloud provider's network. And we, in this way, are interconnecting all of the resources that this customer has in the cloud. So this is all for the cloud connectivity. You have lots of videos talking about Aviatrix transit, highlighting all of the benefits. We do still preserve the express route link to connect the cloud resources to the main data center of this customer. For all of the other branches, we can use another feature from Aviatrix, namely Cloud WAN, to connect all of those sites to their closest region in Azure. It's super simple to do. We actually take care of the configuration of the tunnels on both ends, the branch and the cloud. So it makes it really seamless to integrate that connectivity into this big multi-cloud transit network.
Yeah, this is beautiful, Tomasz. And actually, if the viewer has been watching my videos, I have a video on the access layer and how access layer works with Aviatrix. And we go into Cloud WAN and how seamless it is, how easy it is to connect remote sites via IPsec and BGP to the closest cloud point of presence. and it's all automated. You can have it handle the configuration of both ends, like you said. So the configuration on your iOS device on-prem as well as in the cloud. So it's really seamless way you can onboard sites really quickly and get them into the cloud.
Totally. And now, except for that, you have all of the benefits that you and Frey mentioned, but let me just double click on a couple of them. Insertional firewalls now becomes super easy. And now imagine doing that in the context of the MPLS network, to insert a firewall on the path between your regions in the cloud. That would be really difficult to achieve.
Very hard.
There you go. With Aviatrix, this becomes super, super easy. And as you can imagine, there are lots and lots of customers realizing that there are better ways to interconnect all of their resources than using the legacy MPLS backbone. I think slowly the days of MPLS are coming to an end, especially for those enterprises who have realized that the center of gravity is in the public clouds now.
Yeah, makes perfect sense, Tomasz, and I agree with you 100%. And I think anybody who has been watching networking carefully over the last couple of years would not be able to argue that. It just makes complete sense, and that's where we see the market going.
Couldn't say it any better. Totally agree with it.
Tomasz, one of the things we haven't touched on is the intelligence that's injected into the network when you leverage Aviatrix as a platform for cloud networking. Can you touch on that a little bit?
So it's all thanks to the fact that we have Aviatrix centralized controller managing all of that networking. The controller knows which links are up and are forwarding traffic. The controller would also realize that any of those links went down. And in case the controller discovers that there is some disruption in connectivity on some of those links, it will redirect the traffic to reach its destination using some different path, basically. So you can imagine that in this very scenario, we have this crisscross topology between our transit hubs. If one of those diagonal links fails, which normally would be used to connect, for instance, region 2 and region 4, that's the shortest path. So if this link fails, the controller will redirect the traffic from region 2 to region 4, for instance, via region 1. No big problem for the controller. The controller is the brains of this entire architecture. So it's super easy to change this type of routing decisions. The same goes for your branches. They will normally be connecting in a redundant way to our cloud transit network. So if any of the gateways fails, we will leverage the link to the other set of gateways to still preserve the traffic continuity. The controller will make sure to update the configuration of all of the IPsec tunnels to point them to the new transit gateways now.
Yeah, so essentially what we're doing here is adding dynamic routing protocol behavior to the cloud where it never existed before. We have this functionality where we can calculate the next best path and reconverge and reconfigure the path to get to your destination immediately when we realize there's an outage in a certain region or a certain area, right?
Exactly. And I think for the dynamic routing protocols, sometimes the scale of the cloud deployments could just be blowing through the roof. That might be just too much for them to handle, too much for them to reconverge on. That's why having this centralized place where all of that information is gathered, a powerful instance, a powerful device that would make all of those routing decisions and just push them to those elements that are actually doing the routing.
Yeah.
This is the beauty of Aviatrix.
Yeah, that makes a lot of sense. We've really thought this through to ensure that it would scale to extremely large cloud networks by leveraging this efficient centralized controller. That's a really good point, Tomasz. So, Tomasz, some of my customers have been deploying SD-WAN, and they're going to want to continue to realize the benefits of SD-WAN and their investment as they move to an architecture like this. How can we accomplish that?
Definitely, this is very much possible. We have used Cloud WAN in the case of this very customer just because it fit into their requirements and their existing environment perfectly. However, if the customer already has invested into this SD-WAN solution, imagine that instead of saying Cloud WAN in those boxes, we would simply interconnect with SD-WAN handoff points in the cloud. Each SD-WAN vendor has this type of facility in their environment. So we would establish peering between their handoff point and our transit gateways and have all of those SD-WAN connections get into the public cloud through Aviatrix Transit Network.
Fantastic. Yeah, and if the viewer has seen my other videos, I have 3 or 4 videos on how we integrate Meraki SD-WAN, Cisco Viptela SD-WAN, Silver Peak SD-WAN, VMware, VeloCloud SD-WAN. All of them work in the end, and it's a really nice architecture because you can take all the intelligence you had in SD-WAN and then continue to have that intelligence with the Aviatrix platform. You don't lose any of that path visibility, any of those BGP attributes, any of that traffic engineering behavior you had. You continue to retain that with Aviatrix because our gateways are intelligent solutions, right? They're not just a dumb termination point. They run BGP, they run best path algorithm, etc. So this conversation has been fantastic, guys. I really want to thank you for being here and bringing your customer architecture to discuss with me live on my show.
Thanks, Dana, for having me here again. It's always super exciting to talk to you and share all of the learnings that I've been having with our customers here in EMEA.
Dana, thanks a lot for having me. It's been a pleasure, and yeah, looking forward to the next time too. Thanks.
Awesome. See you guys. So what did Aviatrix do for us in this scenario? Well, Aviatrix allowed us to really easily replace an expensive MPLS WAN with a high performance and reliable CSP-based global WAN while retaining the routing intelligence, the traffic engineering capabilities, the end-to-end encryption, and a lot of automation. It also provided multiple ways for our end users to on-ramp into the cloud efficiently. You could on-ramp via standard IPsec tunnels, or direct connects, or express routes, or leveraging our cloud WAN functionality, or just using your existing SD-WAN. It's all supported and the integrations are published in our documentation, and it works so brilliantly. It made it easy to insert services like next generation firewalls, or really any service you want. I actually have a video on that. If you go back in my playlist, you can watch a video about how we insert third-party services gracefully. It's really a beautiful design. As always, I want to thank you for being here with me today. I can't wait to show you guys what we have coming up next. Take care.